Now, I'm at the Pipelife Academy in Cork, in Ireland, and I'm talking to Mike Geary. I've just had a tour of his establishment here, seen all the different things they're up to. And I've just got a few questions I'd like to ask him afterwards, because we had a look at all those. You can see that in the videos, but I just want to kind of nail him down a little bit, because heat pumps, renewables, the whole thing is still a very contentious issue. Absolutely. In the UK. Now, I know in Ireland there's been a much bigger uptake, there's been a much bigger uptake in the whole of the rest of Europe. But the UK is resisting, even with the increased, the £7,500 that the government is now throwing at people to install a heat pump. There's still a lot of people who are going, it's not for me. One of the issues, which we get over and over again, is noise, and there's planning permission things which are being rejected, so a lot of people who want them can't have them because they can't satisfy the noise thing. You've explained to me that you've got a very, very quiet heat pump out there.
Yeah, the design of the fin of particularly the Medea unit overcomes the tolerance or the turbulence that's caused by the air, which is hugely reduced. So it's one of the quietest in the market. So it should overcome those issues.
So if people have got a problem with the noise, they might do well to look at that or listen to that unit. Absolutely. If they could, and satisfy themselves before putting it in. The other thing, which is unavoidable, is the running costs, because although we've done things with HeatGeek where they've showed that you can make a saving over a gas boiler, for example, or even an oil boiler, a lot of people are finding this isn't the case. A lot of people are finding that their bills have gone sky high since they've had a heat pump. So have you had any experience in this area or not?
Yeah, we certainly do. I think every heat pump company supplier has these queries that come in from time to time, or maybe complaints from time to time. There's many reasons that the running costs would go up, particularly bad design. Particularly in the retrofit market. We always say here, the heat pump should be the last thing that goes into the house. There's no point in having a house built back in the 80s within the building regulations of the 80s and deciding, oh, I'm going to get a heat pump, I'm going to put a heat pump in, I'm going to get my £7,000 grant or whatever the grant is at whatever particular time it is. But that should not be the case. We could sell here in Pipelife, we could sell twice as many heat pumps in the morning if we sold a heat pump to everyone who wanted one. But we have to do a due diligence in terms of satisfaction of the end user, being the homeowner. Bearing in mind, the heat pump is running at a much lower temperature than what the previous oil boiler or gas boiler uses or sends out in terms of temperature. The running cost issue, first of all, there's a perception out there. Okay. Again, in the retrofit market, they say, right, we're spending £3,000 a year on oil, or we're getting 3,000 litres of oil, or whatever it is. If I get rid of my oil boiler and put in a heat pump, that's £3,000 saving per year. That is not at all the case. The electricity bill will go up. Okay, there's no exception. It will go up, and I think a lot of the complaints that are out there is the individual's perception of how much that's going to go up. You will get the feedback from people. Yeah, it will go up a bit, but not to the extent of the 3,000. It could go up to that level and beyond it. But again, particularly with the retrofit market, the heat pump should be the last thing that goes in. The windows need to be upgraded. The insulation possibly on the walls need to be upgraded. The level of control in heating systems that have to be upgraded, and then we'll discuss. Yeah, okay, let's talk about fitting a heat pump into the house. We must move away from that idea of, put a heat pump in and it's going to fix all our issues. When we're designing a heating system, we're trying to achieve the most economical way of running the system. However, it does come at a price. And again, in terms of fossil fuels, it's still much cheaper. In the new build market, the houses are so well insulated. Obviously, that's going to be a much more economical system outside of a retrofit. But unfortunately, it is a necessary evil. If you want comfort in your house, you have to pay for it. Yeah. And I think because you're getting the people are getting their bills on a regular basis, they're forgetting that they had to fill the oil tank last April at a cost of £1,000. Correct. But because it's coming in, and it's more evident obviously in the winter months, you have a higher demand of electricity. There is an awful lot higher demand on applications within the house. We're going down the road of electric cars, a big move over to electric appliances, ovens, hobs, etc. There's a big move away from gas, and all that contributes to the electricity bill, obviously. I do think in an unfair way, the heat pump gets the blame, okay, because it's physically the biggest electrical appliance in the house, so therefore it must be using the more electricity. But when we've done research into complaints of running costs of heat pumps, we would take that, we'd monitor it over 12 months. There's no point in monitoring for a week. We need a wide spectrum in terms of
and years are different. You could have a cold year or a warm year.
Absolutely.
So
yeah, exactly. But generally, when we do a deep dive into a running cost issue, it is very rarely the heat pump. You can have a human error, an immersion or electric heater may have been left on, but generally the heat pump is not the cause of the electricity bill. And
some people say, well, you would say that, wouldn't you? Because
of
obviously
course,
you're selling heat pumps.
Absolutely, but to be fair, we're in the heating industry or the pipe manufacturing industry with over 55 years. We don't say these things blasé. We say it with research behind it. What's very volatile at the moment is the electricity supply market. There's so many different companies offering so many different options. There's introductory offers there that you get a very, very low base price on electricity, and year two, that increases exponentially. That's when we get the phone call saying, we have a problem with the heat pump. But when we go out, we'll put a monitor on the heat pump. You can monitor remotely, and generally it's the fluctuation in price of electricity is the root cause, or something externally.
So what difference practically on the running cost do you think weather compensation makes? Because some people run it without that and some people run it with it, rely on it. So do you think that's a huge significant difference or what?
Yeah, definitely. We've experienced savings up to 25% over a year. Now, there is an understanding as well that, particularly with radiators, there's a little bit of confusion. Particularly if the homeowner experienced life within a fossil fuel environment.
Yeah.
The days of a wet day, cold day, they come in, put their bum up against the radiator and it's lovely and warm, etc.
Absolutely, we all love that. Yeah.
Yes, indeed, I've experienced myself. But with low temperature applications, that's gone. The radiator is never very, very warm.
No, it's surprisingly, sometimes you think, well, this thing's hardly on. How the hell is it heating this house?
Exactly, and it's psychological. If your radiator isn't on or if your underfloor heating isn't on, it must feel cold. But then when we ask, if a query comes in, the radiators aren't working, well, what is your thermostat saying? Is thermostat saying 21 degrees? Well, it is working. It is working. Yeah. So there's a bit of understanding in that, and it's quite difficult to explain to people. Well, your heating system isn't at a high temperature because the outside air temperature is high. So some people say, look, I just want a fixed temperature. I don't want this weather compensation. I just want my house to be hot when I want it hot, and I don't care. And we can set that up as well. But definitely, you're looking at 20 to 30% saving on a weather compensation.
That's incredible.
It's incredible.
I had no idea it was that much. Actually, I'm thinking maybe I'll put one in my own house. But yeah. So from one day to another, the weather compensation for those people who don't know, you've got an outside sensor, which you're telling me is actually in the heat pump.
Correct.
That's measuring the air temperature outside, and it's modulating the heat pump. Is that right?
Exactly that. So the colder the weather gets outside, so we have, say, if the outside air temperature is 5 degrees or below, we're asking that heat pump to generate 40-degree flow temperature. But as the outside air temperature increases, so it might be 10 or 12 degrees outside, well, that heat pump knows, okay, it's warmer outside, so I'm only going to generate 33 degrees temperature. So during the very, very cold period of anything below, say, 5 degrees, it's going to be running at 40 degrees anyway. But when you're coming out of the winter months and going into the winter months, well, the heat pump is going to be running at a much, much lower temperature, and therefore affecting the efficiency of it. And obviously in the summer months, you're not really using the heating, you're only using it for hot water, which is, the heat pumps are incredibly efficient in terms of that. So in the overall 12 months, year on year, it's much cheaper to run it on weather compensation. However, there's a comfort level within the house that needs to be achieved. And
so when it's running on hot water, it's knocking the weather compensation out. That's not even relevant because it's going all into the hot water.
Exactly. So
till it's done that job.
Correct. So when the heat pump goes into hot water production, and when I say hot water, it's the water that's come out of the taps and the showers. The heat pump will divert over to hot water when there's a hot water demand. And the heat pump will ramp up to 100% to heat that tank at the fastest possible rate.
Can you get 60 degrees out of it?
Yeah, with some of the heat pumps that we have, there's a flow temperature of 65 degrees, and that'll give you a tank temperature comfortably of 61 degrees. So it's.
You got any idea about the COP of that? The efficiency must drop, must it? It's 60.
Yeah. So the harder the heat pump works, obviously the efficiency drops. So the COP or the SCOP, the seasonal performance, that does drop down. But again, much more efficient than a fossil fuel or an electrical immersion. Way more efficient. So you could see COPs of maybe 2. Yeah. Bear in mind, it's still 200% efficient over a standard electric immersion.
Which is 100% efficient.
Which is 100% efficient, yeah. So generally we like to design the systems that the heat pump is about 400 to 500% efficient. Yeah. Again, you've challenges with outside air temperature, etc. But over a period of a year, that's the kind of numbers that we'd like to be looking at, kind of a COP of mid 3s to 4.
Okay. So the take home for anybody who's thinking of having a heat pump is, what do you advise first? What's the number one thing they do?
The number one thing to do is they engage with a reputable installer, okay? An installer that has experience in heat pumps, an installer that's not just looking for a fast buck, and do their own due diligence on information that's out there. There's loads of information readily available. I'm a salesman myself.
Yeah.
Do not accept advice from a salesman. Someone that is in the industry long enough that will stand over the system and basically do the research, take responsibility themselves, engage in an experienced installer, reputable installer, and you're halfway there.
So then, heat loss calculations.
Yeah, so engage with an engineer. If the installer, he may or may not be able to do the heat loss calculations. There's plenty of companies out there. We do it ourselves here for the installers. So we'll do a full technical assessment on the house. We will do a heat loss calculation on the house, size the radiators or underfloor heating accordingly, and as well as that, size the heat pump accordingly. We'll do a full designer sign-off. So we're taking the responsibility really from the installer. We're taking responsibility that the design will meet the demands of the house, and that's when the warranty is engaged. Then it's a 10-year warranty for the heat pump, and different warranties for the different components. So once you get the design right, it's installed correctly, and a part of the commissioning. So when there's a handover, we need to sit down with the homeowner and show them how best to use their heating system.
That's interesting, because a lot of them are thinking, I switch it on or switch it off and so on, but with a heat pump I know that you just let the heat pump work it out, you leave it ticking over, and it's maintaining that heat.
Yeah, and that's down to the level of control. So you set your temperatures at a comfort temperature that they want, leave the heat pump do the rest. It's working on weather compensation, and people's lifestyle is different. We can tailor it to whatever their lifestyle is. I would tailor the heating system differently to my scenario versus a retired couple or people working from home. There's different ways we can tailor it to run it at the maximum efficiency with maximum comfort.
It's interesting because although I know about the U values and all the rest of it, when you look at the difference in, say, Cork, which is nicely tucked in down here, fairly sheltered, I'd say, then you go out onto the west coast of Ireland, and you've got next stop America, you've got the wind blowing in, and even though the U values, the chill factor there is incredible, isn't it? So when you start trying to work that out, how you stay warm in those coastal houses with, the absolute temperature is one thing, but we know that it says, okay, it's 5 degrees outside, but it feels like -5.
Yeah.
because of that wind chill. So there's a lot to think about, isn't
There is a
there?
lot to
And
think about.
Perception is very important as well.
There is a lot to think about, and luckily we're on an island. We don't have a huge variation in temperature, but we'll always go to the worst case scenario.
You don't have a huge variation in Ireland. I've been on that west coast.
We're used to it. We're used to it. I think is the difference. Is the difference.
Yeah.
But we tailor it to worst case scenario.
Yeah.
So we will go when we're designing a system. We'll take an average lowest value temperature of the previous, on average of the previous 5 years. So our designs are changing. Climate is changing, but currently, when we're designing a system, we're designing it at -3 outside.
Are you?
Yeah. So when we're designing this, we have to meet the demands of the house when it's -3 outside. But we have experienced in the past conditions that went below -3. But to be fair, we've had no issues. The heat pumps meet the demands. You do have humidity issues here in Ireland as well. Particularly it goes into defrost, can go into defrost more the colder the weather, the more humid, the more moisture in the air.
Yeah, so the damper, yeah. So,
but that's that we'd engage with our install. The homeowner doesn't really have to worry about that. That's we cover that in all our designs.
brilliant. All right. Well, thank you very much indeed. I've learnt a little bit more there. I learnt a lot walking around your academy.
Perfect.
Displays.
Great to see you.